Hello students, let us start a new topic, that is coordination chemistry. So generally, as I have told you, we are having two papers in our subject. In one paper we are having coordination chemistry, which is a very important topic. From our intermediate onwards we are going to learn this topic, which is also very useful for your competitive exams, mainly this coordination chemistry. So let us enter into our topic here. So before entering into our topic, so here the coordination chemistry, how it is going to relate. Okay, so why we are taking metal complexes in this, why it is showing different types of structures, so what are the different types of theories are present in this, so we are going to discuss in this. So now let me explain. Let me explain about the coordination chemistry. So coming to here, on the basis of nature, addition or molecular compounds. So here addition is nothing but what? By combining any two compounds we call it as addition. For example, if you have been taking some NaCl plus CuSO4, it is going to give NaSO4 plus CuCl2. So means what here? By adding two compounds, that one consisting of the addition compounds here. So that addition compounds or molecular compounds, it is going to divide into two categories, that is double salts and coordination compounds. So what is double salts? Double salts is nothing but what here? The double salts mainly exist in solid state only. Only in solid state it is going to exist and is dissociating into particles. So what do you mean by dissociation? Here the dissociation is nothing but here, for example, if you have been taking NaCl, this one will be written as Na plus Cl minus. Okay, so means what? This NaCl molecule, so how it is dissociating? It is dissociating into individual components. Okay, so one is Na plus, another one is Cl minus. So that one we call it as dissociating into constant species. So means what? This is a solid. So this salt, when you dissolve in water, what happens? It is divided into Na plus and Cl minus. So that's why we call it as it is a double salt. And coming to coordination compound, means they're going to lose their water molecules here. Okay, so when you dissolve it in water, what happens here? They is going to soluble and they're forming as a individual components. When coming to coordination compound, so here in coordination compound, what happens? When you dissolve in water, they do not lose their ion, means they do not dissociate into the particles. That one we call it as coordination compounds. I think you have understood these two relation. So this double salt is nothing but what? They dissociate into individual particles. Means what here? When you dissolve in water, mainly we will be taking only solid state molecules. When you dissolve, what happens? It is going to form it as an individual molecule. See here one example. Means what? They lose their identity here. Okay, but coming to coordination compounds, they do not lose their identity. Okay, so here see, let us the example potash alum and more salt. We have taken two types of examples. So when these two are salts, when you dissolving it in water, what happens? It is giving K plus ions, Al plus 3 ions and sulfate ions and also water molecule. So means what? They are dissociating it into particles. That one we call it as what here? This is a double salt which will lose their identity. That one we call it as double salt. When coming to coordination compounds, so here coordination compounds example you take here potassium ferrocyanide we are taking here. When you are taking potassium ferrocyanide, this is also a salt, and when you are dissolving it in water, what happens? It is dissolving, it is giving K plus ions 1 and FeCN6 1. So means what? It is not dividing like Fe plus 6, Fe plus 2 and Cn minus. So means what here? It is combinedly it is formed. Means it is by coordinating it is going to form. Coordination means what here? The coordination is nothing but here. If you take two persons, they'll be having some coordination, right? So means what here? In the same way, if you take two metal atoms or two molecules, so what happens? They, by coordinatingly, they are eliminating. They are not dissociating into individual particles. So this one we call it as coordination compound. Double salt is nothing but what here? Both will be taking in solid, but coming to coordination, we'll be taking solid as well as solution also. Okay. So here coming to double salt, when you dissolve it in water, what here? They lose their identity. When coming to coordination compound, they do not lose their identity. So that's why we call it as it is a coordination compound. Okay. So now let us enter into definition here. What is coordination compound? So coordination compound is nothing but it is a metal ion. I mean complex ion. So the coordination compounds consist of what here? It consists of complex ion, and which is very useful for counter ions. Here the counter ions is nothing but negatively charged atoms, we call it as, simply we can say anions. That one we call it as counter ions. And coming to here, what is complex ion? Complex ion is nothing but what here? Which is represented by a charge with the brackets. That one we call it as complex ion. Okay. So here you take here an example, +2. So this +2 indicates what here? Charge. So whenever it is representing some charge, that one we call it as a complex ion. Okay. So then how it is related to coordination compound? This complex ion, why it is going to relate with coordination compound? Why it is relating to coordination chemistry? Why? Because this complex ion also act like a coordination compound behavior. Okay. So means what we can say here? What is coordination compound? Which do not lose their identity in solid as well as solution state. We call it as coordination compound. So this complex ion, whatever when you dissolve in water, they also do not go to lose their identity. So this complex ion is also known as coordination chemistry. And coming to here, mainly coordination chemistry, transition metals we are going to take. What are transition elements? So these are also known as D block elements. This transition elements is also known as what here? D block elements. So this D block elements, okay, so these metal atoms which consist of positively charged atoms will behave as a Lewis acids. What is Lewis acid here? Lewis acid is nothing but electron acceptor. What is Lewis acid? Lewis acid is nothing but electron acceptor. Then what is Lewis base? Electron donor. So these two consist of coordination chemistry. If you had electron acceptor, if you had electron donor, that one consists of coordination chemistry. So we'll be getting dot. So how these two are related to coordination chemistry? Why? Because here the metal atom you are taking Fe+3. Okay. So here 6N minus. This is one of the ligand. Okay. So here what happens means this Fe+3 will be having less electrons and cyanide ions is going to have more electrons. So then what happens? For example, if I am having two chocolates, my opposite person is not having no chocolate. So means what here? I have to give one chocolate. Means I have to share. So the person is taking the chocolate. Means what? He is accepting the chocolate from me. So means what we can say here? Which is accepting, that when we call it as Lewis acid. Why? Because Lewis acid is nothing but what here? Electron acceptor. The person who is giving, that one he is donating, means what here? Electron donating to the another person. So means what we can say? It is a Lewis base. So by combining these two, we are getting one of the complex, that one we call it as complex ion. Okay. So this is nothing but example. One more example here they have given. So that is Ni+2 6NH3 molecule, NiNH3 6 plus 2. So this is nothing but coordination chemistry, how it is related to complex ion. So let us see the definition. So the complex contains central metal ion. Means what here? The complex, always D block element contains central metal atoms, and here the complex which contains central metal ion or atom bonded to molecules or ions. That one we call it as what here? Coordination chemistry. And coming to here, the Lewis acid is nothing but what here? Metal, which is a center of coordination. And Lewis base is nothing but what here? Ligand, okay, which is a molecules, ions bonded to metal in complex. So here they have given some of the examples. So here in solid state and in solution. So this is nothing but C1NH36Cl3 before adding to the water molecule, which is a solid. When you add water molecule, what happens? The Cl minus will be lost and there will be a formation of the H2O molecules. Okay, so this is also exist in solution state. So by this what we can say here? Species where a transition metals surrounded by certain number of ligands, we call it as what here? Complex ion. Here transition metal ion is nothing but what? Lewis acid. Ligand is nothing but Lewis base. So this is the example we have taken. So this is about general introduction of the coordination chemistry, how it is related with double salts and how it is interrelated with the here complex ion. Okay, let us enter into some basic terms in coordination chemistry. So without knowing those basic terms, we can't identify what is coordination number, what is ligand, coordination sphere, these all. Okay, so first of all I am saying in complex ion ligand, which is the Lewis base. So coming to here, what is the ligand? Ligand is nothing but here, this is a molecule. What is the ligand? So this is the molecule or ion which are coordinated to the metal atom or ion. So means what here? Whether it is negatively charged atoms, positively charged atoms or neutral atoms, it is going to donate electrons or the ligands which are surrounded by a central metal atom. That one we call it as ligand here. Okay, example here we have taken FeCN6. Fe is nothing but here central metal atom. Here we are having 6 ligands. So to this Fe, the ligands are giving electrons. So means what we can say here, the ligands are surrounding towards the Fe atom. That one we call it as ligand, which is the negative ligand, Cn is. So here the ligands can be negative ions, positive ions and also neutral ions. Okay, so this one we call it as ligand. The ligands any type we can take, whether it is positive, negative, neutral. So these are nothing but what here? Lewis base. Why we say Lewis base? Why? Because it is donating electrons to the central metal atom. So this central metal atom, what happens? It is a Lewis acid. Why it is Lewis acid? It is taking electrons from the ligands. Means it is accepting electrons from the ligand. So that's why we call it as it is a Lewis acid. Okay, so we are having different types of ligands, that is 3 types mainly we can say. One is monodentate ligand, another one is multidentate or polydentate ligand, another one is ambidentate ligand. So let us see first of all ambidentate ligand. Ambidentate ligand is nothing but here, it should consist of 2 or more donor atoms. Donor atoms means what? Which will give electrons. That one we call it as donor atoms. So whether it should have 2 or it should have more than 2. That one we call it as what here? Ambidentate ligand we can say. Here example we can take it over here is MnO2 and here also MnO2. So when you do resonance structures of this, so this metal will form only one donor atom. So see here, the metal is going to form only one donor atom, that is with nitrogen 1 atom. After doing resonance structure, this oxygen is going to shift over to the metal. So means what here? Oxygen is also having lone pair of electrons, nitrogen is also having lone pair of electrons. So before doing resonance structures, this lone pair of electrons is donating electrons to metal atom. So that is one. And here oxygen is having lone pair of electrons. So this is also donating electrons now. So means what? Nitrogen is donating, oxygen is donating to the metal atom. So what we can say here, ligand has two donor atoms. That one we call it as what here? Ambidentate ligands. So these two donor atoms is going to donate the electrons to the metal atom. That one we call it as what here? Ambidentate. Now let us enter into mono or unidentate ligand. So what is mono? Mono or unidentate ligand is nothing but what here? Mono is nothing but one donor atom should be present. That one we call it as monodentate. Okay. So here example we are taking H2O molecule and metal atom. So oxygen is having lone pair of electrons compared to water molecule. So which is a H2O is a neutral molecule we can say. Why we say it is a neutral molecule? Because it exhibits as acidic character and also basic character. Coming to here, the oxygen which is donating electrons to the metal atom, that one we call it as here monodentate, means only one atom it is donating electrons. If you take NH3, if you write here, nitrogen will donate electrons to the metal atom. If you take chlorine, the chlorine will donate electrons to the metal atom. That's why we call it as it is a mono or unidentate ligand. And next one coming to here, poly or multidentate ligand. Poly or multidentate means what here? Two or more than two donor atoms it is going to present. That one we call it as what here? Poly or multidentate ligand. We can say here, this poly or multidentate ligands will undergo here different types: bidentate, hexadentate, tridentate, tetradentate. Means what here? Bi means what here? Two donor atoms should be present. If you have been take oxalate, so here we are having two donor atoms. If you take ethylene diamine, here also two donor atoms, that is NH2, NH2. In this also we are having two donor atoms, that is NOH, NOH. Here also we are having two donor atoms, that is NN. Here also we are having two donor atoms, that is OO. So means what? These all consist of here. What happens here? This is all going to contain here bidentate ligand. Hexadentate. Hexadentate, simple example we can take ethylene diamine tetraestic acid, EDTA, which consists of hexadentate ligand. So like that we are having chelating ligand. So this hexadentate ligand will act as a chelate ligand. So what is chelate ligand? They itself will form the ring type of structures. That one we call it as chelate ligands. So that also it is going to contain. So this is nothing but ligands. Okay. So the ligands is nothing but what here? The donor atom, whether it is positive, negative, neutral atoms, the molecules are ions which is going to surrounded by the central metal atom. That when we call it as ligand. Here the ligand consists of ambident, monodentate and polydentate. Ambident is nothing but what here? It should have two donor atoms. That one we call it as ambidentate. Monodentate means only one donor atom. That one we call it as monodentate. Polydentate means what here? Two or more donor atoms. We call it as polydentate ligands. Okay. Next, coming to coordination number. So what is coordination number? Coordination number is nothing but what here? I am turning ligands. Ligand 6CN6, NH3 twice, NH3 4. So means what? The ligand, whatever number it is representing inside the square bracket, that one we call it as coordination number. Means what we can say? Number of ligand atoms bonded directly to central metal atom. In this if you see CONH36, so to the central atom, what is the central atom here? CO is the central atom. So this ammonia molecule. So ammonia molecule we are having 6. So in this we are going to represent amines, that is NH3, which is the neutral ligand here. So this NH36 is representing as a coordination number. Means what? The coordination number of this is 6. And in the same way, if you take here AgNH3 twice. So here two molecules we are having. That's why it is representing 2. Okay. So how many ligands it is going to coordinate with central atoms? The one we call it as coordination number. So for linear we are having 2, for tetrahedral and square planar we are having 4 coordination number, for trigonal, bipyramidal and square pyramidal we are having 5 is the coordination number, for octahedral we are going to have 6 is the coordination number. So next one coming to here, next term is complex ion. So as we know that complex ion is nothing but what here, the central metal atom which represented by a charge and surrounding by ions. So this one we call it as what here, complex ion. This all represents which is bearing with a charge, that all represents what here, complex ion. What is coordination entity? Coordination entity is nothing but inside the square bracket, means the square brackets it is representing and the molecule it is representing. That one we call it as what here, coordination entity. Means what we can say here, the metal atom or ion bonded to fixed number of ions or molecule. Means what it is representing with ligands, no. So the ligand is different here. Coordination number we are going to get 6 coordination number. Complex ion should be with charge. Then entity is nothing but what, which is representing a molecule. That one we call it as entity. Okay. Next one, coordination sphere. So coordination sphere is nothing but what here. So the whole molecule we call it as coordination sphere. So means what we can say here, the molecule they have given. So inside this square bracket, this molecule is coordination entity, which is representing with charge is a complex ion. This number indicates coordination number. This molecule indicates ligand. This metal atom indicates what here? This is nothing but central metal atom. And coming to here, we are having homoleptic, heteroleptic, asymmetric also. Homoleptic is nothing but what here? With same. So with same molecules we call it as homo. Hetero means 2 same molecules, 1 different molecule we call it as hetero. Asymmetric means what? Here 3 different molecules we call it as asymmetric molecules. So this is nothing but coordination sphere and different types of ligands. So coming to here, charge number of complex ion. To the complex ion, how we are going to represent the charge? So charge number of complex ion is nothing but what here? Here we are having outside the square bracket 4 minus. If we take iron atom, so iron is going to represent charge +2. Cyanide is going to represent -6. When you add these two compounds, we are going to have get 4 is the charge. So this is nothing but charge number of the complex ion. Next, coordination polyhedron. Coordination polyhedron means they represent the different spatial arrangement. That one we are going to speak it in the isomerism topic. That one we call it as coordination polyhedron. So this is what here, square planar, tetrahedral, trigonal, bipyramidal, square pyramidal, octahedral. So this is nothing but means for the spatial arrangement of ligand atoms to the central metal atom. That one we call it as coordination polyhedron. Okay. So we are having different types of theories. One is Werner's theory, Sidgwick theory. So what is Sidgwick theory? Sidgwick theory mainly represent about EAN rule. EAN is nothing but electron atomic theory or effective atomic theory. That one we call it as EAN rule. So means what happens here? Which is nearer to the inert gases or noble gases, that should be main important here. So which is then only we are going to get here inert pair effect. Okay. So here when you take Sidgwick electron theory, Sidgwick electron theory is nothing but what? The ligand donate electron pair. So there we are having 3 different types of ligands. So these 3 different types of ligands which donate electrons to the central metal atom and form a coordination bonds. That one we call it as what here? Sidgwick electron theory. What this theory explains mainly here, ligand donate electron pair means central metal atom. So means NO2 will form a coordination, Cl minus will form a coordination, ammonia molecule also form a coordination. Here NO2 represents positive ligand, Cl represents negative ligand, and NH3 represents here neutral ligand. So these 3 ligands which is forming electrons which is donating electrons to the central metal atom. We call it as what here? Sidgwick electron theorem. So this theory mainly depends upon what here? EAN rule. So let us see what is EAN rule. So EAN rule is nothing but what here? EAN rule is nothing but effective atomic number. We call it as EAN rule. So we should know about the atomic number first. How many electrons it is losing, how many electrons it is gaining, or how many electrons it is donating. That all we call it as what here? EAN rule. So let us see what is Z. Z is nothing but atomic number of the metal. X is nothing but what here? Number of electrons lost during the formation of metal ion. So when it is forming metal ion, it will be losing of some electrons. That is nothing but X. Y is nothing but ligands. Number of ligands means number of electrons donated by the ligand. That one we call it as what here? Y. So now coming to here, FeCN6 example we have taken. So in this, Fe oxidation state is +2. Okay, so atomic number of Fe is 26, that is about 26 Z atomic number. X is nothing but what here? Number of electrons lost. How many electrons lost? 2. And coming to here, cyanide. How many ligands we are having? 6. How many electrons it is donating? 2 electrons it is donating. Then we are getting here 36 number. So this 36 indicates what here? Which is similar to the inert gas element. So this, what is the inert gas element here? 0 group elements we call it as inert gas. So what is the atomic number of 36? Which element will get 36 for the atomic number? That is krypton. For krypton we are going to get here 36, which is near. So it is obeyed. What I have told you here, which are obeying the inert gas elements, which are nearer to inert gas elements, we are getting the number. That one we call it as effective atomic number. Here 36 is krypton, so it is obeying the EAN rule. If you are getting 35, it is not going to obey the EAN rule. Okay, so this is nothing but effective atomic number. So now let us see about nomenclature to write the complex compounds. So how to write complex compound nomenclature? Here we are having 3 types, that is positive, negative and neutral compounds. Basing upon these 3 types of ligands, we are going to write the names of the coordination compounds. For neutral compound and for positive compounds, we are getting the same type of names. For neutral compounds, what happens? It is going to represent more number of ligands. If it is representing more number of ligands, then we are going to give according to the order wise. When you take negative ligands, in negative ligands what happens means, at this suffix we are going to get 8. The name of the compound we are going to get here 8. 8 is nothing but what here? At this suffix, for example, and it represent with the charge negative or positive. Neutral and positive compounds will represent with charge positive, and negative compounds will represent with charge negative. Okay, so coming to here, negative compounds always will be having outside the bracket, I mean in left side of the bracket, it is represented with metal, 1A group elements mainly we can say. Not only 1A group, some metals it is going to represent, that is Na, Pt, potassium. So wherever we are getting like these compounds, it indicates what here? Anion compounds. So then we are going to get the, how we are going to name this one? First of all, in anionic compounds we have to name the metal atoms, that is sodium, and here ligands is hexacyano. Okay, hexacyanoferrate. So this hexacyanoferrate, what I have told you, at the anionic compounds we are going to get the suffix position 8, ATE. Okay, so that the metal atom should be at the last. So this is the naming of the compound. So let us see one more example here. Here they have given potassium ferrocyanate. Okay, so means how we are going to write? Potassium will be written first, then afterwards ligand hexacyano, then ferrate. It is going to represent with the 2. So 8 indicates what here? 8 indicates anionic compound. Here you see here sodium they have given sodium and triamine, trichloro, and here platinum. Platinate we are going to get suffix wherever we are getting 8. That one we call it as anionic compound. If the coordination it is neutral or cationic, then it is normally it is used. See here in this. These all compounds are here negative compounds only. For positive compounds, for example CONH36, okay, so hexaamine cobalt 3 ion, okay, cobalt only we are pronouncing, we are not pronouncing cobaltate. Why? Because it is a positive ion, okay. If it is representing with a charge, that one we call it as what here? Positive ion. So this is about nothing but naming of the compounds in coordination chemistry.